Okay, we've looked at the chain rule algebraically, but now we want to look at the chain rule through table values. And we want to look at the chain rule graphically. These are the three ways that you're going to see it on the AP exam. All of these are excellent AP exam type questions. The algebra stuff that you were doing is actually more difficult than what you're going to see today. This looks very confusing, but it's really not bad. So suppose that f of x, big F, is equal to f of g of x, and f of 3 is 2, g of 3 is -1, f prime of -1 is 1, g prime of 3 is 4. Find f prime of 3. Well, where do we even start? We start right here. We want to find f prime of x. And the derivative of a composition function, that's what you need to identify in the AP exam. You see f of g. So therefore, you're going to use the chain rule. And the chain rule says we take the derivative of the inside. What would we write as the derivative of the inside? How would we write that? What's the inside function here? G of x. So the derivative we would write as g prime of x times the derivative of the outside, f prime of, with the inside left alone. Right? That's what we've been doing, right? Derivative of the inside times the derivative of the outside with the inside left alone. That's the phrase you need to kind of get through your noggin. So we've got f prime of, we're trying to evaluate f prime of 3. Well, now it's easy. We have g prime of 3 times f prime of g of 3. Hello. Thank you. Oh, awesome sauce. Okay. So what is g prime of 3? 4 times f prime of, what is g of 3? So now I have 4 times f prime of -1. What's f prime of -1? Not too bad, huh? Well, what you have to do is you got to be able to set that up. And now you've seen it. But that's the idea. And you guys, this is what I always come back to. Because when I see these problems, sometimes I see one that's not written like I've seen it before. And I always think of this. The derivative of the inside times the derivative of the outside with the inside left alone. And that's what we do with the boxes, right? Derivative of the inside is the right box. Derivative of the outside is the left box. And then the arrow is the inside left alone. That's what we're doing. Okay, let's try another one. Given the following graphs, let u of x be f of g of x, and let w of x be g of f of x. Find u prime of 1 and w prime of -2. Well, I'm going to look at g. I'll draw it in blue so we can see it better. And then f will be in red. You can see it better. So I'm going to start with this. U prime of x. Somebody give me a rule for u prime of x. G prime of x. Good. And I'm trying to evaluate u prime of 1. So I've got g prime of 1 times f prime of g of 1. Let's look at the graph. What does g prime of 1 mean? What does that mean graphically? Because it says find u prime of 1. What does that mean? What does g prime of 1 mean, graphically speaking? The derivative at 1. What does derivative at 1 mean? That means, what are you doing? Slope. She's finding the slope at 1. I locate the function g at 1 right here, and I say, what's the slope? Well, that's just a line. And you can tell that that line has a rise of 3 and a run of 1. So very good. So that's 3 times f prime of g of 1. Well, so that's f prime of, what does g of 1 mean? G of 1 means the location. Where is g at 1? It's at 2. So f prime of 2 means what is the slope of f at 2? Negative 2. Kitty, you were here second hour, right? Did you write that down? We got the same thing? What? Okay, that one's right though. I don't remember that. Like it's blank from my memory. So that's what I was wondering. Did I make a mistake? I think that's right. Yeah. Okay. Very good. All right. You try the next one, but it says w of x is equal to g of f of x. So it's switched around a little bit. Okay. It's not f of g, it's g of f. So you got to write a little bit of a new rule. Try that. And I will slowly work behind you. Did you get 1/4? Question? Going once, twice, thrice. Last example. Back to our old problem we started with. Given an equation, or find an equation for a line tangent to the curve at a given point, we need two things: point on line and slope. Do we know the point on the line? 1, -1. How do we find the slope? Take the derivative. What's the derivative of the inside? 2. What's the derivative of the outside? 5u to the 4th. So it'll be 10u to the 4th. How do I find the slope? What do I plug in? What's 2 times 1? -3 to the 4th times 10. Y plus 1 is equal to 10 times x minus 1. Put in slope-intercept form. Done. Go get some brain food, folks. When you come back, rest time is yours to work. So the quicker you get back, the more work time you have. Yep. You see how I get that? So then I plug in 1 for x, because we're wondering the derivative at an x value of 1. And 2 times 1 is 2 minus 3 is -1 to the 4th is 1 times 10 is 10.